Today we're doing a really important video because it's come to our attention that half the people out there that watch tech videos don't actually know what lots of the terms mean. And to be honest, we didn't know some of them either. So we've done some research and we're going to be explaining to you guys exactly, or to the best of our ability, what some of these things mean.
We're going to go through these quickly. Okay. RAM is random access memory, and basically it's like your immediate memory. So when you open a tab or a game or something, you're using RAM, but when you close it, it's gone.
Okay, so the graphics processing unit in a phone has one job, and this is to take a 3D point which has been programmed on the X, Y, and Z axes and use a mathematical equation to then convert this into a shaded region on a display. This will make it appear as if you've got a 3D model on the screen, when in fact it's been converted into two axes.
So, a CPU. The CPU is like the brains of the computer. It's the central processing unit, and it's responsible for executing a set of instructions called a program. So it takes a set of inputs from an input device and processes the inputs and outputs the results as the output device. That's it. The chipset, it's the motherboard of your device. So basically it's what everything connects to. Make sure everything is compatible, like your CPU, GPU, RAM, and also it determines the extent to which your device can be overclocked. So like it limits the performance depending on the temperature of your device.
Well guys, enough of that. We're going to talk to you briefly about the cores. So people always mention cores, and what they are they're small sections of the CPU inside the central processing unit. So their role is to take information, input information. So say you click the home button on your phone, this sends a signal to the core. The core then takes this information, uses mathematical calculations to generate a response, and then it will trigger a response using what it's worked out. So if you've clicked the home button on the screen, once it's gone through the core, the core will then change the page that you're on in the software, for example. Another big thing which confuses many people, and confused myself until like today, is the aperture on the camera lens. So, I mean, like, what is it? It's all about how much light actually gets through the camera sensor, and therefore how naturally bright your image is. And what do they mean on the spec sheet where they say f1.5 or f2.0, for example, on the spec sheet? So like, this can be confusing, but f is the focal length, and this is the distance. Within a camera, you have a curved glass, and this is the distance from the outside of the curved glass, so the very furthest point on the glass dome, and then if you go into the camera to the point where all of the light is refracted into one point, and from that point all the way back out to the tallest point on the glass dome is the focal length. And then what they mean when they say f1.5, they actually mean f divided by 1.5, and that gives you an answer. The answer is the aperture. The aperture is the diameter of the hole which lets light into the camera. And the number after the f in spec sheets, for example 1.5, is actually the scale factor, so almost like the ratio between the distance, the focal length, which I explained, and then the actual diameter of the hole which lets light in. This ratio is really important because if you think about that, you're dividing the focal length by the scale factor, and this gives you the aperture. That means that the larger the scale factor, say it's f2.0 compared to 1.5, the smaller the diameter of the hole which lets light through will actually be. So if you take two cameras with the exact same focal length, then they're basically equal to each other. But then you have one with 1.5 for the scale factor and the other with 2.0. You divide, say the focal length is 50 millimeters. 50 millimeters divided by 1.5 will actually give you a bigger value, so a bigger aperture, which lets light through, than if you divide 50 millimeters by 2. And therefore, having the bigger number after the F, so dividing by a bigger number will give you a smaller aperture. That's why the numbers seem to be reversed on the spec sheet. That's why 1.5 is actually better than 2.0 if you have the same focal length.
Pixel density. Okay, pixel density is measured in pixels per inch, or PPI. And basically what that is if you imagine there's a diagonal inch on a screen, it's how many pixels make up that diagonal inch, and that's PPI. Resolution. Resolution, you might have heard of 4K, 1080p, 720p, 480p, and basically what those numbers are the horizontal number of pixels on a screen. So if you have 4K, you have 4,000 pixels in a horizontal line across the screen. If you have 1080p, you have 1080 pixels in a horizontal line. Aspect ratio. Aspect ratio is basically the ratio between the height of a screen and the length of a screen. You might have heard of many phones in 2018 having 19:9 aspect ratio. The number of pixels height-wise and length-wise is exactly the same as the aspect ratio.
Now I'm going to be talking about the camera sensor and then a bit about the image processing. This section of the spec sheet can be a bit confusing because they normally talk about things like 1/2.6 inches. Now this might seem confusing at first, but all this is the entire diameter or width of the camera sensor. So say on the Google Pixel 2 XL, they say 1/2.3 inches. That is equivalent to around 6.7 millimeters or something. And if you actually measure the diameter of the camera on the back of the phone, it actually matches this. So that's all they're saying. So you might see on the spec sheet, for example, in the same section, 1.22 micrometers, or an equivalent similar number. And all this means, it's talking about the size of each pixel within the camera sensor. And a pixel within a camera sensor is what actually absorbs the light, so basically sees the image, if you will. And the larger the pixel, each pixel, the more photons, so the more light it can capture. So that's all that's referring to, the size of each pixel within the camera sensor. Another thing in a similar section of a phone spec sheet is gyro EIS, and another thing you might see is OIS. The gyro EIS is simply referring to the electronic image stabilization. And the way this works is it has a gyroscope and it can detect how far you, for example, tilted your phone on an axis. And then it will use electronic software, so mathematical calculations, to try and correct the image electronically after it's already been taken to cancel out the movement. This is okay, but in newer phones, on, for example, the Samsung Galaxy S9, we expect OIS, Optical Image Stabilization, and this is where there's physically a gimbal, for example. There's physical movement within the actual camera sensor to oppose the change. So if you tilt your phone to the right, the sensor will then tilt to the left just as much to keep the image facing the same direction. And this is generally a lot more accurate and better.
So now we're going to talk about the difference between LCD and OLED displays. What are they? Well, an LCD display, or liquid crystal display, is basically liquid crystals in front of a backlight, and basically the backlight lights up the display, and the liquid crystals form the image, which is pretty cool. But then the OLED display, or organic light emitting diode display, is where when each individual LED receives current, it lights up, and so you can target specific areas to light up, so you can achieve like darker blacks and just more contrast really. And that's why you can have always on displays, which is pretty cool, like on the Google Pixel 2 XL. But yeah, OLED is where the future is. I mean, LCD was kind of in the past, so we're not going to see any more of those, hopefully. We're going to talk about 3 types of USB: USB-A, USB-C, and micro USB. So USB-A is probably the most common at the moment, and it looks, the port just looks like this one here. And basically it's just kind of like it's a rectangle, and it kind of, lots of people say it looks like a duck bill, but I don't see why. Sorry, what was that?
What's happening?
No, I'm actually interested to have your input here. Micro USB is probably the second most common at the moment. It's used in most phones, and yeah, well, it used to be used in most phones. In 2018, however, most devices, or lots of devices, are now using USB-C, which is good, because it's kind of a mixture between micro USB and USB-A. So it's combining the two really.
So now I'm just going to briefly talk about SSDs and hard drives. So, you know, there's a bit of confusion about what the difference is, and it's quite simply that hard drives use moving parts, so mechanisms and things like this, to function, whereas SSDs are simply solid state drives. They don't have any moving parts. Everything is done through electrical signals. Some people think that, in fact, SSDs are definitely the way to go in 2018, and this is because with moving parts in hard drives, you often get, well, not often, but like after a long use, you can have malfunctions where, say, like a moving part gets stuck or it breaks. You basically like lose a ton of information. Okay, now I'm gonna briefly go over FPS. If you didn't know, FPS stands for frames per second. It's pretty simple. And the general theory, and like from practice, is that the more frames per second, the higher quality the video. For example, everyone knows that, for example, 30 frames per second is worse than 60 frames per second if you're looking at footage. But, you know, this isn't always the case. So, for example, you see things like super slow-mo, which is around like 960 frames per second or something like that. And people think, well, why isn't this the best quality video ever? To make the video slow-mo, what they've done is they've actually reduced so it films the video in 960 frames per second, but then they spread that over like 6 seconds, so technically it's no longer anywhere near that number. It's no longer anywhere near 960 frames per second when you watch the video. That's why the quality isn't as good. But then with that, since you've stretched out, you get to view the video much slower than it would be in reality. The reason, from what I understand, that they don't just film 960 frames per second in normal time, where you would get like amazing quality video, is that if you think about it, with the slow-mo you can only film 0.2 seconds of footage, and this takes up quite a lot of storage. If they were to allow you to film normal video for minutes in 960 frames per second, your storage, your phone wouldn't be able to cope, because the storage would be maxed out within like a minute. It would be crazy.
mAh, milliamp hours. Basically, it's a measure of the charge in your battery. Basically, well, the higher the number is, the more charge it has. So you have a 4,000 milliamp hour battery, better than a 3,000 one. Most phones these days use lithium-ion batteries, and basically what those are batteries that contain an electrolyte solution with lithium ions and electrons mixed up in there. And basically the electrons have to float through the phone in order to get back to the lithium ion, where they recombine to become a lithium atom. And when charging a phone again, the ion and the electron splits again, so the electron flows around the phone again, and the process restarts. Lithium-ion batteries. And the good thing about lithium-ion batteries is they can hold a lot of charge. A lot. High dynamic range, or HDR, is basically where the color spectrum on your phone is larger. So you have darker blacks and brighter whites. And so basically it just creates more contrast in your image, which makes it look better. Makes it look more vivid, more real.
So one of the last things we're going to talk about now is, what does megapixel even mean? So obviously mega means a million. So 1 megapixel is 1 million pixels. And generally people think that the more pixels you can get, so the more megapixels, the better. The reality is that this is only true if it's within the same space. So say you have like a 1 by 1 centimeter sensor and you have one megapixel in that space. That's worse than having 2 million pixels within the same space, because you get more pixels in, which means the resolution of the image is much better. And we talked about resolution earlier. The last thing I'm going to talk to you about is Hertz. So what is Hertz in terms of processors? So in processors and CPUs, they normally talk about gigahertz, which is a billion hertz. And a hertz is the amount of instruction. Hertz is the amount of instructions that a processor can complete in 1 second. So the amount of actions it can like generate in 1 second. It takes in the information and generates an action. How many times can a processor do this in 1 second? And that's what they're telling you. In other cases, it would be, for example, with a light bulb with AC current. In this country, it flashes 50 times a second. So that's the amount of actions it can complete in a second, 50 flashes of the light bulb. And basically, in general, the more it can complete per second, the better. So a higher gigahertz number means that it can complete more tasks in 1 second.
We both learned quite a lot today. I've learned a lot. I'm sure you have too, hopefully. But it's been good, learning about this stuff. If you like the video, you should obviously tap that thumbs up. But if you loved it, truly loved it with your heart, just subscribe. It's down on this side.